take us through a little bit about SIMOC and give us the live demonstration. And so Ezio, take it over.
Hi, hello everyone. Can you see my screen?
Yes, we can see your screen.
Perfect. So I'm Ezio Melotti. I'm the lead front-end developer for SIMOC, which is a scalable interactive model of an off-work community. And today I'm going to tell you something about our project and show you a live demo. So as human nature always pushes us to explore and settle into new place. And of course we start here on Earth, and we always wanted to go outside. We want to go on Mars, we want to go on the moon, and you see there are as someone mentioned previously in another talk, that there are a number of nations that are planning trips either on the moon or on Mars. And this is turning from science fiction to reality. And as you can see in this image, this is an artist rendition of our third or fourth generation colony on Mars might look like. And this is at the moment is still science fiction, but what we want to do is making this reality. And of course, there are a lot of challenges. And one of the most basic challenges is how do we sustain human life in an hostile off-world environment, such as the moon or Mars. And one essential component that we need is the so-called ECLSS, which stands for Environment Control and Life Support System. And there are two main kinds of ECLSS. So one is a machine-based physicochemical life support system. And this is something you might find on the International Space Station. So on the International Space Station, there is this ECLSS, a machine-based ECLSS. And what it does is making sure that all the people there have enough air, water, that there is the right temperature, the right humidity. We also take care of the human waste disposal, of recycling, for example, water. And on the ISS, this is done mechanically, so with devices. It's a physicochemical, machine-based. The second kind instead is what we call bioregenerative life support, which means it's like plant-based. So instead of machines processing all this water and air and like converting and recycling, we are doing this using plants. And of course, you're all familiar, I think, with the Biosphere. And during the 90s, there were two main experiments here, which set world record, where people lived inside the Biosphere. And this demonstrate, the goal of this project was, one of the goals was to demonstrate the viability of closed ecological system to support and maintain human life in outer space. Because if we can do it here on Earth, this is the first stepping stone to actually doing it on the moon or on Mars. So the goal is to create a system able to sustain life, which is as simple as possible, because of course the more complex it is, the more difficult it is to realize. So we want to find a way to sustain life which is both functional, so that works and let people live there for extended period, but also simple enough that we can actually afford to do it and build it and maintain it, because the more moving parts you have, the higher is the risk of failure. And so this was the first experiment in the 90s, and more recently in China, the Beijing University built this lunar palace, and this was in 2015, so it's quite recent. And here we did a similar experiment, and we had plants. We were actually growing like 5 kinds of cereals and 15 vegetables. And another interesting things that we did is to provide food for the people living inside this lunar palace. They're using yellow mealworms. So we have a system in which the humans, the plant, and the mealworms help each other, and for example, the plants can provide the oxygen, and the waste from the plants get eaten by the mealworms, and then the human eat the worms as the main source of proteins. So this is like very interesting how you can survive in this way. And here I also want to point out that when you have like a machine-based system, then it cannot provide food. So on the ISS, you need to bring food ration regularly. And if we do a mission on Mars or on the Moon, of course you understand how difficult it is to bring food there. And whereas with this system, you can actually produce food there in a sustainable way that works long term. And we can also have hybrid solution. So you can have both machines and plants that work together to provide what a human needs to survive. And if we take a small step back, you can see how the Lunar Palace uses this system, which is kind of complex. It has like several agents. We have like plants, we have the crew, we have the storage, we have the yellow mealworms, and all these agents have to interact, and they exchange oxygen, CO2, and other things. And this brings us to SIMOC. So what we want to do is being able to simulate all this complex interaction between all the agents. And we built this software, which is based on an agent-based model with a plant, human, solar panel, and so on, and currencies of exchange. So we keep track of all the exchanges that happen between these agents. So we have O2, CO2, we have water, we have waste, and other element, electricity, power, and so on. And we wanted to make it flexible so that it can simulate both the machine-based and plant-based system, and also hybrid system. And you can see here, I don't go into details, but you can see how complex it is. So we thought about everything. And this is based on the work of Ray Wheeler, which pioneered these studies and gave us the foundation to work on this. And here you can see like a zoomed in. And again, we don't have all this, but the system is designed to be flexible and allow simulation of every sort of environment. And to give you some more detailed example, these are the data for the human. So we know how much oxygen or CO2, how much oxygen they need, how much CO2 they produce, how much water and food they drink and eat, and so on. And we have also data for plants. And we know for each plant, we have data based on previous studies that tell us for a lot of different plants. So this we already have them in the system. And I can also show you the way we are doing this. So we have this file. Let's see. Okay, let's do it like this. So we have this file, as you can see, is quite long, where we write down all the values for all the agents. And this is quite easy to create new agents. So you can just write down the file. The file you can write how much the agent consumes and produce, and you will see you can use it inside the SIMOC. And I want to give you a live demonstration. So this is, we partner with National Geographic. So this is currently live. We launched it this summer. And you can create a new configuration. You can also load data. And here you can configure the simulation. So you have different presets. You can set the location. Currently we only have Mars, but we're planning to add the Moon. The mission duration, how many like people are in the crew quarters. The size of the crew quarters, how many inhabitants. And you can set a lot of parameters here, as you can see. I start with a simple preset, so just one human and a Niklas, no plants. And when you launch the simulation, you can see we have different panels. and we start receiving data from the server, and it calculates the step. So this is a 10-day simulation, so 240 hours. And here we can move forward and back in time to see how all these agents interact. And you can see, for example, here at the top, we have energy production and consumption. So the blue one is the production. And you see it goes up and down because we modeled a function that matches the sunrise, like the sun rises and set, and the solar panel here in the morning, they start producing, getting energy when we reach a peak like during midday, and then as the sun is setting, it goes down. And you see the consumption here, it goes up and down a bit depending on which devices are running. And another thing I want to point out, for example, at the beginning here, if you look at the CO2 production and consumption, here there's a constant is produced constantly by the human here, the inhabitants, and you can see here in the atmospheric monitor how it's raising. And you also see here in the inhabitant status that the CO2, we monitor the level. So if it's too high, or if there's not enough food or not enough water, we get a warning. And you see here there is a peak of consumed CO2. And this is the E-class module that is kicking in. You can also see here the electricity being consumed. And after we reach a certain point, at the beginning, the humans start consuming the oxygen and producing CO2. At some point, we reach a level that is high enough that we need to start the E-class at regular intervals to scrub the CO2 and remove it from the atmosphere. And I also have another simulation here. I prepare to save some time. So this is a more complex simulation. Here we have 4 inhabitants and a greenhouse. So you can see the different plants. You can see here how the plants are growing. Of course, it takes some time. And one important thing is, even though all the data are deterministic, so we know how much each agent produces and consumes, once we put them together, we get surprising interactions. So here, for example, you can see which part of the E-class are running. Here you can see the CO2 production and consumption. And here, as the plant grow, they take in more CO2 and give more oxygen out. So at this point, we don't need the E-class. For example, the CO2 reduction sabatier is not running. But as we harvest plant, they don't get CO2 in, so we need to run the CO2 reduction sabatier again. So we start from simple data and we get very complex interaction. And the last thing I want to show here, you can, for example, change panels. We have like several panels that allows us to track different things. And you can customize, you can import and export data, and you can, it's like very flexible, and we are working constantly to make it better. So I think that's it. And I want to let Kai close this talk with some last note. Just a quick note about this. The architecture is based on a client and server. So this, the one you saw in the browser is the front end, the client, and the server uses this agent-based model to produce the data. But now Kai is going to tell you what are our plans for the future. So go ahead, Kai.
Thank you, Ezio. It feels good to have designed and invented SIMOC and to have someone else do a better presentation than I could have done. So thank you so much. I'm actually going to hold my portion of this until maybe towards the end of the QA or even the end of the day, because I want to give Anastasiya her allocated time. But thank you so much for the presentation. Sure. And then I will talk later about SIMOC as it integrates with SAM.